As I said, systems like imperial English measurement, they're good if you want to be able to get quick estimates. They're good if you want to be able to say, okay, my hand is about this big, so this thing is about 5 hands long or wide or what have you. There's obviously a bit of looseness that I have slightly above average hands, but some people have very tiny hands and some people have incredibly large hands. So it's a little bit loose if you need something incredibly exact or specific. And that looseness very much did characterize these measurement schemes historically. Because one person's hand wasn't the same as someone else's hand, if you took your stuff to one trader in one town and went to a different trader in a different town, they might not have the exact same sizes. They might not talk about things in exactly the same way. And obviously, especially for things like trade, this caused problems. And so it should make some sense that a more standardized system would emerge from France, starting in 1670 with work by Gabriel Mouton, who suggested a decimal system based around the longitudinal length of the Earth centered on Lyon, where it's important to note here for historical context that in terms of decimal numbers and the Arabic numbers being used in Europe, that happened, we may have talked about this a little bit earlier on in the semester, around the year 1000, and well into the 1500s, people were still writing in terms of Roman numerals. So the way that we were thinking about things for decimals, it wasn't quite where we are right now. It's worth wondering whether or not the effect of systems like this may have had on that eventual adoption. But anyway, while the thought Mouton had was appreciated to come up with a standard system, there were some problems with propriety, as it would be in that time, over the next 30, 40, 50 years, that more and more accurate estimations of the Earth's circumference were computed, where scientists were finding that the Earth is not perfectly spherical. So it's a little bit oblong in places, and as a result, longitude can vary a slight amount based on location, where as a result, when the French tried to take the idea, not quite Mouton's, but one that had developed off of it, to England and America in 1790 so that they could build a standard measurement scheme, supposedly both the English and Americans rejected it because the English wanted it to be centered on England and the Americans wanted it centered on America. So the French ended up going their own way, as it were, and they would develop what became the metric system.
You know what they call a quarter pounder with cheese in France?
No.
Tell them, Vincent.
Royale with cheese.
Royale with cheese. You know why they call it that?
Because of the metric system?
Check out the big brain on Brad. You're a smart mother.
Where, fittingly, this also occurred in the time of the French Revolution. And those of you that don't know a whole lot about the history of France, this was a period of great upheaval in the country, where a great many things changed and a great many heads were guillotined off, but that's a topic for a different class. What we have to talk about here are some of those things that changed with the measurements of things, where one idea that they had was the Republican calendar of 1793, where they want to decimalize the way that time is told by splitting the year into 100-day and 10-month periods, but that idea didn't quite catch on. The one that did was what would become what we call the metric system, as I said, where metric comes from French, obviously, the word mètre meaning measure, as in 1790, a 5-person panel of France's best scientific minds was convened. This including Borda, Lagrange, Laplace, Monge, and de Condorcet, to investigate and put together a system for describing the way things are measured, for describing measures. And over the next 5 years, they would put together, along with work from others in the scientific community in France, the problem of setting a notation for these measurements. And on April 7th of 1795, the metric system would be defined into law. And apologies to the French in the audience. I've taken French before, but my pronunciation was never very strong. And over the next few hundred years, this system would become the most commonly used in the scientific community and in the world at large.
There's the measurement system, which is just, America, you guys have your own thing, the imperial system, you know? On my side of the world, we use the metric system, and by my side, I mean the rest of the world, you know? We have the metric system, which is, amongst other things, very efficient. It's a very simple process. You know, everything goes into each other. And out here you have imperial, which is fine. I won't judge you. If you want to be imaginary, that's up to you.
Where it would evolve into the Système International des Unités, or SI units, as you've probably heard in your high school chemistry courses, in 1960. And this system, as we said, is defined by powers of 10, that we use the prefix kilo with the symbol K to measure that we are taking 1,000 of our base unit. Hecto with the symbol H means 100. Deca with the symbol DA means we are taking 10. Deci with the symbol D means we're taking a tenth. Centi with the value there C means 1/100th. And milli with the letter M means 1,000. Point is, here we have our decimal system that is the most popular in the world. It's one that everyone except for us, Liberia and Myanmar, basically uses, where it is a reasonable question to wonder why America hasn't adopted the metric system. And the answer to that is, for one, it kind of has. That in the scientific community, as a result of things like the $125 million crash of the Mars orbiter in 1999.
With that, basically, we're at the point where I think we can safely say our expectations for the success of the mission are remote at this point.
Which was caused by a bad conversion between the imperial and metric units. Generally, people like NASA and the overall American science community do use metric for the sake of being consistent with everyone else. We gotta learn from our mistakes. That's the process of history. But it's not adopted everywhere, obviously, as we still have signs that are measured in miles per hour instead of kilometers per hour. And we talk about ounces of liquid instead of looking at the liters of them, although you will often see both, and they are a little bit interchangeable in some contexts. But more than anything else, the reason why it's not taken hold everywhere in America is a result of just inertia. There have been serious efforts in the past to bring about the metric system to America as a whole, but it's expensive to change all of those things, all that signage, all the way that things are discussed. And for the average person, it's not actually worth that much to change, besides getting into sentiments of American exceptionalism, and how we should be special and have our own nice system for describing things. It's all very political and something that is more effort than it's usually considered to be worth. And next, getting past all of that stuff, all that history, all those politics in there, we're going to talk about how you actually convert between metric units and then get to how you can convert from English to metric and vice versa.